Good morning. Good morning to all. Today we will be discussing about reinforced cement concrete introduction, session 2. In the previous session 1, we had discussed about plain concrete, advantages of plain concrete, the concept about compression and tension, compressive strength as well as tensile strength, which led to the low tensile strength of the concrete. Then we had discussed about reinforced cement concrete, types of reinforced cement concrete, advantages. So that was a brief discussion about session 1. Now in this session we will be discussing about the structural part. The overview of my presentation is as follows: the introduction, structural analysis and design, objective of structural analysis and design, the various design codes, different types of loads acting, grade of concrete and grade of steel, the design philosophy, reference. Now coming to the introduction part of structural analysis and design, the study of the structure such as reinforced concrete structure or any other structure, we encounter two different types of problems, that is the analysis and design part of the structure. Although the same principles are used in both cases, solving the problem requires different procedures. Coming to the analysis part, it deals with how much force is applied on the structure. The analysis is done before the design part is taken up. Analysis is a process to determine the response of or behavior of the structure under some specified load or load combination. The analysis process is done by some assumptions. The assumptions include dimension of all structural elements, loads, material properties, support conditions. The sizes are generally assumed either by experience or by thumb rule. Whereas coming to design, it is related with shape and size of the cross section so that it can safely transfer the load. It is a process to find out the safe, durable and economical specification of the structure. The economical specifications include material, geometry, the size of the structure, member which is sufficient to carry loads of the structure during the life period of the structure. In more simplest terms, we can say analysis as finding the capacity of a building and design as finding the sizes of the building. For example, let us consider a mild steel wire of 3 mm diameter. To find out what weight a mild steel wire of 3 mm diameter can carry when the weight is freely suspended, this is an analysis. In contrast, what diameter of the mild steel wire is required to carry the given weight is the design. Now, solving a problem requires certain data or certain properties. Generally, what are the properties given in analysis and design problem? Let us see. Generally, it is in a structural analysis problem, following properties are given, such as cross-sectional dimension, number of reinforcement, reinforcement diameter, location of the reinforcement, strength of concrete and strength of steel. This will be given. Whereas in the design problem, design loads, design moments and load factors will be given. Now the results obtained will be resistance, strength and capacity in analytical problem, whereas in the design problem it will be suitable cross sections, dimensions, material strength and reinforcement detail. There will be some specified solution obtained in structural analysis, whereas in case of structural design there could be many possible solutions. Usually, since all parameters are given, the solving of analytical problem is easier. However, in case of design, there are many choices available and a lot of decisions have to be taken to solve the problem. Hence, design is a tedious process. Now, coming to the objective of structural analysis and design. Any structural analysis and design problem should satisfy stability, strength and serviceability criteria together with economy of the structure and looking into aesthetics also. It should provide stability to prevent overturning, sliding or buckling of the structure under the action of the load. It should give strength to resist safely the stresses which are induced by the loads in various structural elements. Serviceability to ensure satisfactory performance under the load and to control deflection, crack, vibrations occurring within the acceptable limits as specified in the code. Together with this, it should be of reasonable cost and also it should give a good appearance. These were the few objectives and discussion about structural analysis and design. Now coming to design codes, various countries have specified various codes for the building design. Likewise, in India, we have Indian Standard Code IS 456-2000 for plain and reinforced concrete. Together with this, we follow SP 16/1980. Now, for design loads, we consider IS 875 Part 1 to Part 5 1987. For earthquake loads, we consider IS 1893-2002 and revised version 2016. For ductile detailing of reinforced concrete, we consider IS 13920-1993. This was about the codes given in India. Now, what are the different types of loads which will be acting on a building? There are usually two types of loads, that is vertical load and horizontal load. Vertical load is nothing but the load which is acting vertically, such as dead load, live load and snow load. Dead load is nothing but the weight of the structure or the self weight of the structure, such as beams, columns and slabs. Live load is nothing but the furniture or the equipments which are present inside the building, some other extra items which are kept inside the building contribute to the live load of the building. Snow load is nothing but the snow which is acting on the roof of the building, which occurs usually in the icy areas. Apart from this, we have horizontal load such as wind load and earthquake load. So these are the various types of load which will be acting on a building. So what is the path of this load to get transferred to the soil? Let us look into that. We have gravity load, which is nothing but the vertical load which is acting on a building. This includes dead load and live load. Live load because we are assuming that certain occupancy such as furnitures are kept inside the building. The vertical gravity load which acts on a building or a slab, the load from the slab gets transferred to the beam. From the beam, the load gets transferred to the column. From the column, the load will get transferred to the foundation, and from the foundation, it has to get transferred to the supporting soil. So this is the load transfer path. Apart from this, let us see what are the grades of concrete and grade of steel given for the calculation purpose by IS code. The grade of concrete are defined by the strength and composition of the concrete. There are different mixes given. Various mix proportion for various ingredients of cement, sand and coarse aggregate is given by the code. Here M stands for mix and number represents characteristic strength of 150 mm cube for 28 days. So these are the grades given in the code. We have ordinary grade concrete, standard grade concrete and high strength concrete. Ordinary grade concrete, which starts from M5 to M20, which characteristic strength is given in MPa or Newton per mm square. So here M represents the mix and the number represents the characteristic compressive strength of the concrete. Similarly, the standard grade of concrete starts from M25 to M45. High strength concrete from M50 to M70. Similarly, grade of steel is given as per IS code, such as mild steel Fe250, cold twisted bars, that is high yield strength deformed bars are given. The yield strength of mild steel is 250 MPa. Similarly, the yield strength of cold twisted bars is 415 MPa and 500 MPa. These are the different shapes of the bars. Design philosophy. Coming to the present trend of practice, that is limit state method. Prior to this method, there were many other methods which were tried in practice, that is working stress method and ultimate load method. In working stress method, it is defined as a method used for reinforced concrete design where concrete is assumed as elastic. The assumption states that both steel and concrete act together elastically and the relationship between load and stresses are linear. However, in practice, this assumption is not true. The response of the building will be non-linear, and also the elements which were used were not slender sections, it was very big sections, and it did not accommodate for combinations of different load combinations, as of which this method was a failure. Now coming to ultimate load method. In this method, it was possible to consider the effect of different loads acting simultaneously. This was the shortcome of working stress method, which was satisfied in ultimate load method. And because of the ultimate strength of the material, we get much slender sections for columns and beams compared to working stress method. But the serviceability criteria was not taken care, which led to deflection and cracks, and hence this method also was a failure. Now coming to limit state method, which is followed in the present scenario. This method is the advanced method over working stress method and ultimate load method. Limit state is defined as the acceptable limit of safety and serviceability requirement before failure. That is, the structure should be able to withstand safely all the load that are liable to be acting on it throughout its life, and it should also satisfy serviceability requirement of limiting deflection and cracking. There are two types of limit state methods, that is limit state for collapse, which deals with the strength of the building, limit state for serviceability, which deals with deformation of the building. In turn, both the methods are classified into four parts, that is limit state of collapse, we further classify it as limit state for flexure, compression, shear and torsion. Limit state for serviceability is further classified for deflection, corrosion, cracking and vibration. Lastly, coming to the design loads, compressive strength of the cube, characteristic load, characteristic compressive strength of the cube. These three definitions are taken from the code book IS 456-2000. Apart from this, we have partial safety factor. These are the factors which are applied to the loads and materials to arrive at the design value. The partial safety factor for limit state of collapse and limit state of serviceability is also given in IS 456. The partial safety factor for material such as concrete and steel. Here, the design strength of material FD is given by this formula, where F is the characteristic strength of the material, gamma m is the partial safety factor appropriate to material and limit state considered. Gamma m in case of concrete is taken as 1.5 and in case of steel it is taken as 1.15. The difference is because the steel is usually manufactured in the yard or the industry where the specifications are taken care of, whereas the concrete is prepared in the field where many malfunctions may take place or discrepancies may occur, and hence the partial safety factor for concrete is taken as more. Similarly, the partial safety factor for load is given by this formula. So this was the discussion about this session 2 about brief introduction regarding the structure. We discussed about the introduction to structural analysis and structural design, difference while taking up the problem, the data which is given, results obtained. Then what was the objective of structural analysis and design? Then we looked into the design codes, various types of loads which were acting on the building. Then we took up grade of concrete and grade of steel. Then finally the design philosophy and design loads. So this was the brief introduction about reinforced cement concrete. These are the references which are referred to prepare the material. Thank you for your patient hearing.